Hey guys, Mr. Middleton here. Today we're going to talk about biconditionals, inverses, and contrapositives. At the end of this lesson, you should be able to write a biconditional and determine when one can be written. You should be able to write an inverse and a contrapositive of a conditional and determine their truth values. Okay, this is a continuation of yesterday's lessons about conditionals and their converses, and so just kind of review that a little bit here with an example. So if two angles have the same measure, then they are congruent. We have that conditional statement. You can tell it's a conditional statement because of the if-then of it. Okay, and so they're asking us for the hypothesis. Remember, the hypothesis is the first part, but does not include if. So the hypothesis in this situation is two angles have the same measure. The same measure here. The conclusion would be the part following the then. They are congruent. They are congruent. Okay. And the converse would be flipping the hypothesis and the conclusion. Okay, so if two angles are congruent, angles are congruent, comma, then they have the same measure. Whoa, there's no measure. Okay. So that's a review from yesterday. Remember truth values, we were able to tell whether a statement is true or false. So the truth value of the conditional statement, the original conditional, if two angles have the same measure, then they are congruent. That is true. That's what congruent means. And then the converse says if two angles are congruent, then they have the same measure. Yep, that's true. That's what congruent means. I have to try to recenter this. Alright. So, now, let's go on to the new aspects of biconditional. A biconditional can be written when both the conditional and the converse are true. So only when the conditional and converse are both true. To write one, you take the hypothesis and the conclusion and you separate them with the phrase if and only if. If and only if. This happens if this is true and only if this is true. So we're going to write the biconditional. As you notice up here, our conditional we set was true and its converse was true. So that means this statement, this conditional, can be written as a biconditional. So let's write it. We'll say two angles have the same measure. Two angles have the same measure Now here's our biconditional words, if and only if they are congruent. Alright, put it all on the line. Okay, so there's our biconditional. Alright, now it says write the biconditional of the statement of the following conditional if possible. Okay, now that lets us know, or that should make us think, what does that mean if possible? When is it possible to write a biconditional? Only if the conditional and its converse are true. So this statement, or conditional statement, says if two lines are parallel, then they do not intersect. Okay, that's true. If two lines are parallel, they don't intersect. But we have to think about the converse. The converse of this situation would say, if two lines don't intersect, then they are parallel. And that is false. Okay? Converse is false. We cannot write that. We couldn't say that two lines don't intersect if and only if they're parallel, because two lines don't intersect if they're skew as well. Okay? So the counterexample for the converse is skew lines. Excuse me. All right. So here we go. Let's say let's write a conditional statement and a converse of this biconditional. So here we're given a biconditional. We're going to write the conditional statement. We're going to write the converse of that conditional statement. You get an A an A plus if and only if you get a 98% or above. So our conditional, not too hard to write. If you get an A plus, then you get a 98% or above. Okay, that's the conditional. Now the converse just flips the hypothesis and conclusion. If you get a 98% or above, then you get an A plus. And A plus. Okay. Alright? And so there we have it. Remember that in our conditional statements, the if and only if part are not either the hypothesis or the conclusion. So those are our hypothesis and conclusion. Alright? Flipping to the back side. We're going to talk about inverses and contrapositives. These statements are conditional statements with special characteristics. Okay, an inverse statement negates both the hypothesis and conclusion. Negates. Okay, basically it's like arguing, negating something is like arguing with a 4-year-old. Okay, or if you hear 4-year-olds argue. Okay, it just says the opposite of whatever's being said. So let's practice. Number 1, the dance was fun. To negate that statement, you'd say the dance was not fun. Okay, you wouldn't say the dance was boring or the dance didn't have enough people. You'd say the dance was not fun. The opposite of what they said. Okay. Number 2, the figure is not a square. Well, you wouldn't say, oh, it's something else. You'd say the figure is a square. The figure is a square. Okay, in this situation, you can think of it as adding another not. If I say the figure is not a square, not double negative means it's positive. Okay, the figure is a square. Now, inequality signs are a little bit tricky, but that's why we have them here. If we say x is greater than 10, what's the negation of that? Well, that means greater than 10 has to be wrong. So anything that's not greater than 10 is right. So we'd say, a lot of people would say, well, x is less than 10, and that's true, but also equal to 10. Because by them saying that x is greater, the statement saying x is greater than 10, if it were equal to 10, that would also prove that statement to be false. So we'd say, well, it's less than or equal to 10. Okay? Alright, so that's how we negate a statement. Alright, so let's look at it. It says write the inverse of the conditional, determine the truth value of each. So all we're doing for inverses is we're negating both the hypothesis and the conclusion. So we'll say if x squared does not equal to 36, comma, then x is not equal to 6. Okay? So the conditional, truth value of the conditional, if x squared equals 36, then x is 6. That's actually false. Okay, because if x squared is 36, it could be negative 6 as well. The inverse, if x squared is not 36, then x is not 6. That's true. Not 36, 6 squared has to be that. So, yeah, that's true. Oh, my paper's all crooked. Sorry, guys. All right. A contrapositive flips and negates the hypothesis and conclusion. Flips and negates the hypothesis and conclusion. Think of it as the converse of the inverse. Okay. So write the contrapositive of the statement above and determine its truth value. So we'd say if x is not equal to 6, okay, because flipping and negating. If x is not equal to 6, then x squared is not equal to 36. Okay. Now let's determine this truth value. This is false. Okay, because if x is not equal to 6, it could be equal to negative 6. And negative 6 squared would be 36. So, this is false. Alright. So here we go. Last example. Write the conditional, converse, inverse, and contrapositives for the Venn diagram. Determine the truth value of each. The conditional, if you are an NFL player, then you are a football player. Okay. If you're an NFL player, then you are a football player. Is that true or false? That's true. Okay, I'll circle these here. Okay, the converse. It flips the hypothesis and the conclusion. If you are a football player, and I'm going to just abbreviate this as FP, comma, then you are an NFL player. And I'll just say NP. Okay. Now, if you play football, then you're an NFL player. That's false. Okay. The inverse flips or negates the conditional statement, both the hypothesis and conclusion. So it says, if you are not a NP NFL player, comma, then you are not a football player. Okay, and that's false. You can play in college or in high school or the Canadian League. Okay. The contrapositive, remember, flips the inverse, or you can think of it as the flips and negates the conditional. So it says, if you are not a football player, comma, then you are not a NFL player. And that's true. If you don't play football, you can't play in the NFL. If you look at this, looking at these four conditional, converse, inverse, contrapositives, and also the examples up here, you should notice something about the truth values for the contrapositives. Okay, the truth value for the contrapositive is always the same as the conditional. And actually, you'll see that the converse and the inverse also always have the same truth values. Okay? Alright, a lot to take in for inverses, contrapositives, and biconditionals, but hopefully you're able to identify them, write them, and use or say their truth values. See ya.